by first multiplying by the square root of x squared plus x over the square root of x squared plus x, find the limit as x approaches infinity of the square root of x squared plus x minus x. So I've selected this one. It's quite a challenging question. It does at least give you a hint as how to do it. It's not an easy limit. If you just were to plug values in, as in substitute infinity, you'd have the square root of infinity squared plus infinity minus infinity, so it doesn't really mean anything. There will, without wanting to spoil it too much, there will be a nice finite limit for this. We're looking really to create instances. A lot of these limit laws boil down to this, that you have the limit, lim as x approaches infinity of something like a 1 over x, that makes a 0. You have the lim as x approaches infinity of something like 1 over x squared equals 0. We're looking to kind of create instances of this. So hopefully you've looked at it and you realize that this is a difference of two squares thing going on. The square root of x squared plus x over itself, that's obviously 1, so we're not changing the value of the thing we're trying to find the limit of once we do this multiplication. And if you look at it, it's kind of like I want to say radical conjugate, but it's kind of too complicated to really call it that. But you can see if you had, it's like an a minus b, a plus b, difference of two squares thing that we're doing, but it is quite complex. So let's just do what it says and see where we can get to. We are looking to find the limit as x approaches infinity of, but the original thing is x squared plus x, the square root of that, minus x, and then what we're doing is timesing that by the square root of x squared plus x over itself, the square root of x squared plus x again. So if I just kind of put brackets around that, hopefully you can see this difference of two squares. If we say a is the square root of x squared plus x and b can be x, you've got a minus b, a plus b, right? So we know that a minus b, a plus b, once you expand it, it goes to a squared minus b squared. So a squared would be all of this, the square root of x squared plus x squared, which would just be x squared plus x. So this is going to be the lim as x approaches infinity of, so we said this is x squared plus x, and then you've got, that's your a squared minus b squared. Well, b is your x, so minus x squared. So you can already see at least the numerator is looking quite nice already. Over, well, this is just there on its own, so that doesn't change. Square root of x squared plus x. Right, so looking at that top, you can say x squared, they disappear. So you're just left with x on the top. And now this is really, I did want to show you this one because it's quite a tricky bit of maths that it does. Hopefully you won't have to use it in an exam situation, but I certainly can't guarantee that you won't. So we're looking to see if we can get a common factor of x in all these three terms. We've got an x here and an x here. So can we be creative and pull an x out of here? So for an x to come out of this square root, it would have to be an x squared in there as a factor, really. So let's see, so equals the limit as x approaches infinity of x, that's just the top, over, so in this square root sign, I'm going to just pull x squared as a factor. So x squared times, well, the first term's easy, x squared times 1 gets you x squared, and if you want to know what you times x squared by to get x, well, just divide x by x squared. That will give you 1 over x. So 1 plus 1 over x. That's the square root sign, and we've still got the plus x. Right, so now you've got x squared times something else. Using the laws of surd, you can just pull that out of the square root and it will just be an x. So now we've got the limit as x approaches infinity of x over, so pulling this x squared out, so that would be x times, and that will be 1 plus 1 over x, 1 plus 1 over x, and plus x, like that, and then I can pull another x out. I've got 1, 2, 3 terms, all with x as a common factor, so I can say equals the limit as x approaches infinity of x over x as a factor, 1 plus 1 over x, 1 plus 1 over x plus 1, like that. Right, so now I can say cancel an x with an x, so a 1 and a 1, and suddenly this is looking really nice. So now this is the limit as x approaches infinity of 1 over 2 plus 1 over x. So if you remember your limit laws, you can do these separately. So the limit of the quotient is the quotient of the limit. So I can find the limit as x approaches infinity of 1 divided by the limit as x approaches infinity of 2. And remember, if there's no x in there, then these are just the number. So this is going to be 1 over 2 plus, and then the limit as x approaches infinity of 1 over x, which we've set up here, is 0. So this ends up being 1 over 2 plus 0, so the answer is 1/2. And I'm not going to do it here, but if you were to get your calculator and plot the original function on a graph, and then sort of go way off to the right, you would see a vertical asymptote appearing at y equals 1/2. So you would see it approaching a finite limiting value of 1/2.